Welcome to Elcor Technologies Inc. In this video, we will discuss troubleshooting steps for rectifying measurement reading discrepancies. If you have not yet done so, please review the installation video, linked in the description, as proper installation is key to achieving accurate measurements and is most often the cause of measurement problems. Warning: the advice in this video is for guidance only. All installations must be done by properly trained and certified personnel according to local and national building standards and electrical codes. Dangerous high voltages may be present during the installation and troubleshooting process, and the appropriate precautions are necessary. Never work on live circuits. Rewiring CTs should only be done if the CTs are shorted through a meter or shorting block, or preferably when the system is de-energized. This is especially important when working with 5 amp CTs, as they can generate high voltages when disconnected from a meter or shorting block. While millivolt, milliamp, and Rogowski coil CTs do not generate the same dangerous output voltages, this should not be relied upon for safety. In this video, we'll cover the recommended steps to diagnose suspected measurement issues. This video will only cover discrepancy with readings and not functional problems such as lack of communication or other performance issues. When dealing with reading discrepancies, it is first critical to determine the source of the problem. The meter measures voltage, current, and the phase relationship between them. Correct power and energy readings depend on the proper installation of voltage and current inputs, as well as proper configuration of CTs and PTs. Having access to live meter data is critical to diagnosing and correcting measurement errors. This is most easily done by reading the data through the onboard display itself or a remote terminal such as Modbus Commander, third-party data logger, or monitoring platform. This video assumes that the CT ratio, and PT ratio if required, have been configured into the meter using either the onboard display or remote Modbus terminal. Please review the installation video as well as Elcor's support resources for more information. First, check the voltage measurements. Do they match what is expected, and are they generally uniform? In split and single-phase systems, unconnected voltages will read 0 and can be ignored. Next, check the line-to-line voltages. Are they what is expected? Again, in some cases, depending on the system type, some of the parameters may not be relevant and/or missing, so it is important to know which parameters are expected. If there is a discrepancy, use a voltmeter to confirm the voltages at the terminals of the meter. This can be done between the respective phase and neutral inputs, as well as between phases themselves. Loose connections or improperly seated terminals can cause missing or errant readings, so ensure that the wires are properly installed into the terminals and the screws are torqued correctly. Repeat the process for the phase currents. Do they match what is expected? In most systems, the currents should be fairly uniform, although some variation between phases is normal. If there is a discrepancy, try using a clamp-on meter to confirm the measurements. It is also possible to measure the output of the CTs to confirm the signal coming into the meter. However, this method depends on the CT type being used. Contact Elcor for more information. In installations which include a shorting block, ensure that it is in the open or metering position. If the problem still persists, especially if it is in one phase only, try to swap the CTs between a working phase and the errant phase. If the problem continues to stay with the errant phase, it may suggest a problem with the meter input. However, if the problem follows to the new phase, then it suggests a problem with either the CT itself or a connection between the meter and the CT. Ensure that the CTs are wired back to their correct locations after performing this test. After confirming the voltage and current measurements, for the moment, disregard the power measurements and observe the per-phase power factor. Ignoring the sign, the power factor should be as close to 1 as possible. A negative power factor is usually okay so long as the absolute value is close to 1. Values, ignoring the sign, above 0.9 are usually normal. Power factor values above 0.7 should be considered suspect, and below 0.7 are usually a sign of installation error. If this is the case, especially if the power factor is low in 2 or more phases, it typically indicates a voltage and current mismatch. Inspect the CT phasing to ensure that the voltages and currents are in the correct phase with one another. CT phasing refers to the correct matching of voltage and current inputs. More specifically, the CT connected to the IA1 and IA2 current input terminals must be installed on the same phase that is tapped into the VA terminal, and so on for all phases. This is imperative for accurate meter measurements. The results of mismatched voltage and current inputs will influence the readings for power and power factor, and thereby energy. This is a common installation mistake. This can be corrected by either swapping the voltage inputs or the current inputs to ensure that each phase matches. The meter does not care what the order of the phase inputs is, only that the voltage and current inputs match for each respective phase. Lastly, observe the per-phase power measurements. Ensure that the magnitude of the power readings is consistent and in line with expectations. Observe the sign of the power measurements and ensure that each phase is measuring as required. The desired sign of the power is chosen by the system operator depending on what is to be measured. In most cases, it is desired for positive power to represent consumption, that is, import. In this case, the source is considered the grid and the load is considered the facility. If the meter and CTs are installed as per LCOR's documentation, power imported from the grid will be positive and accumulated into the import energy register. In the case where the facility has the ability to generate power, if the meter and CTs are installed as per LCOR's documentation and the grid is considered the source, exported power will be measured as negative and accumulated into the export energy register. If the sign of the power is opposite to what is expected, first check the CT phasing as discussed in the power factor section. Incorrect voltage and current phasing into the meter not only results in lower than expected power measurements, but can also cause negative power readings. If the phasing is correct, then reversing the sign of the power measurements may be achieved by either swapping the orientation of the CT on the conductor or reversing the polarity of the CT into the meter. Doing one is the same as doing the other. If the CT polarity or orientation is reversed to correct the power sign while the phasing is incorrect, then it will just compound the problem by fixing the symptom and not the cause. This is why it is important to focus on the power factor readings prior to correcting any power sign discrepancies. It is important to understand how energy is accumulated and calculated. When power is positive, energy is accumulated into the respective import energy register. This occurs on a per-phase basis. When power is negative, energy is accumulated into the respective export energy register. Both the import and export energy registers are always positive. Net energy is the result of subtracting export from import. As a result, if the export value is larger than the import value, the net energy register can show a negative reading. Finally, the total import, total export, and total net energy registers are calculated as the sum of all individual energy registers. In the case where the meter was installed incorrectly, and therefore measuring power and accumulating energy erroneously, the energy readings will be wrong. There is no way to alter the energy registers, so the only solution is to reset them to 0. Please refer to the documentation and support resources for more information. We hope that this video has been useful in highlighting some of the common installation mistakes and methods to identify and correct them. For more support resources, check out our support site at support.lcor.net.